Okay, so apologies for that. Once again, we are doing calculus. All right, so calculus. Let's just start from scratch. So calculus. Calculus can be divided into two parts. We have differential calculus, and we have integral calculus. Integral calculus. Okay, so differential calculus. The things that you're supposed to learn are the first principles, you're supposed to learn the power rule, you're supposed to learn trigonometric differentiation. Okay, you are supposed to learn logarithmic differentiation, and you're supposed to learn rules. There's the product rule, there's the quotient rule, there's the chain rule, there's implicit differentiation, and then there's parametric differentiation. Then at the end of all this, we have applications. And under applications, this is where we have maxima and minima. Okay, so that is differential calculus. Integral calculus. Integral calculus, we have the power rule, and then you're supposed to learn about the U substitution, okay, then you're supposed to learn about what's this, integration by parts, and then you are also supposed to learn about integration of piecewise functions, and then basically you also do at the end of it all, we're going to do definite integrals. Okay, so this is our map basically. So calculus is going to can either be differential calculus or integral calculus. Differential calculus, we have first principles, and you're going to do this individually. Please look at kinematics. Kinematics, part 1. Okay, so today's focus is going to be the power rule, trigonometric differentiation, logarithmic differentiation, and then I teach you product rule, quotient rule, and then we quickly go to implicit differentiation. This is very hot, and chances are you may have quite a number of questions on implicit differentiation because it can be quite challenging. Okay, it can be very, very, very challenging. So we're going to learn the power rule, we're going to learn trigonometric differentiation, logarithmic differentiation, product rule, quotient rule, and then implicit differentiation. Then in another session, we're going to do the other parts that we haven't. Okay, so by the end of this session, you should be able to answer the following questions. Who didn't do kinematics? I can avail you the kinematics document, and then you can just do the first part of calculus. Yeah, just the first part. It's just like 5 pages, so the document is there. It will make things a bit faster. All right. Then, in the next session, we're quickly going to do the power rule on integration. We're going to quickly do the use substitution, integration by parts, integration of piecewise functions, and then we are also going to learn definite integrals. Okay. Now, by the end of this session, this morning session, you should be able to answer the following. You should be able to differentiate a function such as tan x, okay? You should be able to differentiate a function such as cot x. You should be able to differentiate a function such as cos inverse of x. You should be able to differentiate a function such as 2 to the power x. You should be able to differentiate a function such as x to the power sin x. These are high probability exam questions. So pay attention to each and everything that will be taught. Okay. So we can start. The power rule. The power rule is the most basic. So power rule basically says multiply the coefficient by the power and subtract 1 from the power. Okay. And then how do you know they're asking you to differentiate? How do you know you are required to differentiate? How do you know? So phrases used. So they may say find d dx, okay? They may say find an expression for the gradient, okay? They may say find y prime, this is read as y prime, or they may say find f prime of x, okay? So they're quite, or they may just say find the derivative of, sometimes they'll say find dy dx. So whenever you see any one of these phrases or expressions, you know they're asking you to differentiate. Now, one of the quick methods to learn when you're differentiating is the power rule. What do you do for the power rule? Multiply the coefficient by the power and subtract 1 from the power. Okay. So algebraically, this is going to be like this. If you have ax to the power n, and they say d dx. Now, the letter they want you to focus on is the one that comes after the d. Pay attention to this. The letter that they want you to focus on is what comes after the d in the denominator. So here we have the x after the d in the denominator, meaning they want you to focus on x. They want you to differentiate x. So you're going to multiply the coefficient of x by the power of x, and then you subtract 1 from the power of x. So d dx of a x to the power n is going to give us, this is going to be n a x n minus 1. Notice I have multiplied the coefficient by the power. This gives me n times a. And I have subtracted 1 from the power. This gives me n minus 1. Okay. That's basically. And then if you have a constant that is an item without a letter, okay, it just disappears. Now the question is why? Why does this happen? Imagine you've been asked to differentiate d dx of 3. Okay? 3 is a constant because it doesn't have a letter attached to it. It doesn't have a variable. Okay? If it had a letter, it would have been 3x, 3x squared, 3y, and so on. Now, if there's no letter, it is as good as having, maybe for instance, x to the power 0. So, differentiating this using the power rule, I'm going to multiply 3 by 0. This is going to be 0 times 3. And then I'm going to write the x, and from 0, I'm going to subtract 1. This is going to be 0 minus 1. Now, anytime I multiply anything by 0, my answer will just be 0. Okay, the red pen has run out. So anytime I multiply anything by 0, my answer will just be 0. Okay, so anytime you multiply, you differentiate a constant, it simply just disappears. What if you're asked to say find d dx of maybe 3x? Now, notice that this x has a power of 1. If they've not included the power, then you have a power of 1. When you differentiate something that only has a letter that has a power of 1, the letter just disappears. Okay? So this is going to be, when you differentiate this, this is going to be 1 times 3, and this is going to be x, 1 minus 1. Okay? This is just going to give us 3x to the power 0. Now, whenever you have x to the power 0, x to the power 0 is just 1. Okay, so basically this is just going to be 3. So 2 important rules. If you differentiate a constant, it simply just disappears or you get 0. If you differentiate an item that has x to the power 1, the letter just disappears. So the quick way will be d dx of maybe 5x. Okay, the answer will just be 5. But d dx of 5 would give us 0. So that's the power rule. Easy stuff. Easy, 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 easy stuff. Fialambox asedidin. Fialambox asedidin. We now go to trigonometric differentiation. Trigonometric differentiation. Okay. Now, you can't understand trigonometric differentiation if you've not done trig. That's why a lot of time was spent trying to teach the basics of trig, because all the topics that followed after required you to have a basic understanding of trig. Okay, like as you can see, trig has appeared under calculus. So trigonometric differentiation, we use the mnemonic. We use the mnemonic state cancel. Now, all mnemonics are going to appear silly until you need them. And if you remember, where else did we use the mnemonic state cancel? Who remembers? Where else did we use the mnemonic state cancel? Who remembers? You can comment. Where else does the mnemonic state cancel apply? Where else does the mnemonic state cancel apply? Who remembers? Where else does the mnemonic state cancel apply? Where else? Where else? Where else? Who remembers? What else do we use the mnemonic state cancel for? I think I mentioned it in class. Okay, trig. Yes. Okay. Quadrants. Quadrants. Nope. 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 Okay. So identity is under trig. Yes. For instance, if you want to know what sec is, okay, inverses. Eesh. So if you want to know what sec is, you use the state cancel. So reciprocal identity is good. State cancel, for instance, if you have sec, sec is related to 1 over cos. If you have cosec, cosec is related to 1 over sine. And the state cancel mnemonic under trig will be important actually when graphing functions like sec and the like. So, state cancel. S actually represents sine. C is going to represent cos. If you differentiate sine, you are moving normally from S to C. So the answer is going to be positive. Okay? But if you differentiate cos, you are moving against the norm. Okay? So the answer is going to be negative. So this mnemonic is going to help us remember the derivative of sine and the derivative of cos. So d dx of sine x is going to be, according to state council, I'm starting with sine and I'm moving in the normal direction. So my answer is just going to be positive cos x. Okay. Now, it's not always that sine is going to come straightforward as it is. It could be a double angle, it could be a triple angle, or whatever. So this can also be d dx of sine ax, where a is any number. If you have 2, this is a double angle. If you have 10, this is whatever. Okay, so the answer here is going to be, so if you have a number in between the ratio and the x, the number is going to become the coefficient, but the number will still maintain its position in between. So this is going to be a cos ax. Pay attention to the a and how it has been distributed. Okay. Next, d dx of cos x. State council. I'm starting with cos and I'm moving against the norm. Starting with cos, moving against the norm, my answer is going to be negative. So the derivative of cos is going to be negative sine x. Okay. Next, d dx. Cos can also have something in between the way sine had. So this could be d dx of cos ax. This is going to be negative a sine ax. So these are the important trigonometric derivatives. Now, it's not always that they'll use x. They could also use theta. Okay, so let's use some examples. Remember, what they want you to focus on is what comes after the d. So if they put theta here, then the expression should have theta as well. Examples. Find d theta of sine 5 theta. What do you think the answer is going to be? What is the derivative of sine 5 theta? Use the appropriate rule. Actually, let me even help you. Use this rule. What's the derivative of sine 5 theta? What is our answer? Quickly comment. These appear silly, these appear useless, but you're going to see when we start applying them in very challenging questions, then you're going to see the relevance of making sure the basics are understood. What is the derivative of sine 5 theta? What is the derivative of sine 5 theta? Excellent. So you have an answer. So this is going to be, no, 5 sine 5 theta. Nope, nope, nope. Careful. Sine is going to give us cos, state council. Okay. So this is going to be 5 cos 5 theta. Excellent. Easy stuff. We can now move. So I'll ask you later to say, what mnemonic do we use under trigonometric differentiation? So pay attention. And the person who won airtime yesterday didn't text me. Only the person I mentioned should text me. I got quite a number of texts from various people. No, only the person I mentioned should text me. So during this session, I may ask you what the mnemonic was for trigonometric differentiation. So pay attention to it. Let's go. Logarithmic differentiation. So you see, to understand calculus, you should have understood general algebra, you should have understood trigonometry, and you should have understood logarithms. So log differentiation. Log differentiation. Who remembers what the mnemonic BAM means? BAM. It's very important. Who remembers what the mnemonic BAM means? This is also a good revision session, right? Because some of the things you thought you could remember, you actually realize you have forgotten. So this is good for revising. What does a mnemonic BAM mean? Okay, according to the way that quantum taught logs, what does a mnemonic BAM mean? So base, answer, middle. So base to the power answer. No one is phrasing it right. So phrase it properly. So base to the power answer is equal to what is in the middle. Excellent. So if I have a log, for instance, log base, then whatever I'm going to have here, we refer to it as the middle part. Okay? Okay. This helps us know what part I'm talking about. Okay. So whenever I talk about the middle part, I'm referring to what comes after the base. Whenever I talk about the middle part, I'm referring to what comes after the base. So for logarithmic differentiation, here's how you go about it. Number one, ignore the log, comma, differentiate the middle item, then divide what you get by the original middle item. Okay, excellent. So ignore the log, differentiate the middle item, then equate what you get by the original middle item. Now, logs, so you can have any log. You can have any log. What do we call a log that has a base of e? So log base e, how is it simply written? What do we call log that has a base of e? Log base e, how is it simply written? Log base e, how is it written? How else is it written? Log base e. When the log has a base of e, how is it written? How is it written? How is it written? ln x, where is the x coming from? So it's just ln 9. Some people would say lean. Where the e and the n come from, I don't understand. So it's a natural log or Napierian logarithm. Okay. So ln log base e is basically just ln. Some people would say lean. I don't know where the e and the n come from. Now, you can have any log. You can have log base 10, log base 5, log base what. It doesn't matter what log you have. You simply ignore the log and then differentiate the middle item, then divide what you get by the original middle item. Example. Find d dx of ln x. What's the middle item of ln x? What's the middle item of ln x? According to the way we have expressed logs, log, base, middle item. So if you have ln, you know the base is e. Now, what is the middle item of ln x? What's the middle item? I'm not asking for the overall answer, just what's the middle item of ln x? What's the middle item of ln x? Quickly. N. E. What's the middle item of ln x? Remember, the middle item is what comes after the base. If no base has been included, then you're dealing with a base of e. So the middle item for ln x is x. Excellent. Okay, so the middle item for ln x is going to be x. So this is the middle item. So to differentiate a log, we said differentiate the middle item and then ignore the log. So this part is going to be ignored. The way some of you are ignored by your crushes when you text them. Okay, so you can relate. Fine. So most of you won't have issues learning this topic. So you ignore ln, you focus on the middle item. I'm going to differentiate the middle item and then divide whatever answer I get by the original middle item. So in simple terms, this is going to give us d dx of ln x is going to be the derivative of the middle item. The middle item is x. So derivative of the middle item is going to be 1. Remember, this x, d dx of x, the coefficient is 1, it has a power of 1. It will be 1 times 1, which is going to give us 1. I subtract 1 from the power, I'm going to have x to the power 0. So remember I told you, if you just have a letter that has a power of 1, the letter just disappears. So all you're left with is the coefficient of the letter. So derivative of x, remember we said to differentiate logs, ignore the log, differentiate the middle part. So this is the derivative of the middle part. And then divided by the original middle part, which is x. So basically, this is going to be differentiate the middle part, then divide what you get by the original middle part. I hope this makes sense. So the derivative of x is going to be 1. The original middle part is going to be x. So the derivative of ln x is going to be 1 over x. Okay, let's try something else. Let's try something else. Find d dx of ln x squared. What do you think the answer of d dx of ln x squared is going to be? So we're going to give you a minute to try, and then you compare your answer with what I'll get. I need to make sure you guys understand these basics so that when we need them, I know you have understood them. Okay. What do you think the derivative of ln x is? So differentiate x squared and then divide whatever you get by x squared. Chapa. So what's the derivative of x squared and the like? Like what's the overall derivative here? So 2x over x squared. Okay. Now, if you notice, the person that has said 2x over x squared, the x's can cancel out. So this is going to be, the derivative of x squared is going to be 2x divided by the original middle item is x squared. X squared. Now, if you look at x and the x squared, they can cancel out. You see that? So this is going to be 2x over x times x. These two x's can cancel out. These two x's can cancel out. So the final answer is going to be 2 over x. I hope you guys are getting this. So trigonometric differentiation, we use a mnemonic, state cancel. Okay? Know the 5 derivatives. For sine purely, for cos purely, and when sine has something in between and cos has something in between. Then logarithmic differentiation, okay? Ignore the log, differentiate the middle item, and then divide what you get by the original middle item. So the answer here is going to be 2 over x. Now, let me teach you another rule. If you have a coefficient in front of the log, multiply your final answer by that coefficient. For instance, you could have been given find d dx of 2 ln x. Okay? So I am going to differentiate ln x, and then whatever answer I get, I'll multiply it by 2. Remember that the derivative of ln x is going to be, so this is going to be 2 times, then the derivative of ln x. The middle part is x. I differentiate x, I'm going to get 1. Over the original middle part is just going to be that. So the answer here is going to be what? 2 over x. Now, there's a reason I have given you these 2 examples. If you pay close attention to them and you understand logarithmic rules properly, you realize that this is actually the same question. Why am I saying this is this? Like, what property are we using? What ability of logs have we applied for us to move from here up to here? Why am I saying this is the same question? What ability of logs could have been applied for us to move from this question for us to end up with such an expression? What ability of logs was applied? What ability of logs was applied for us to move from this question to this question? They are the same question because they're giving us the same answer. They're both giving us 2 over x. Because a base, are you sure? A log can make a coefficient become a power, or a power becomes a coefficient. You understand? So it's the same question. So it's up to you. You can either drop the 2, make it a coefficient, then you differentiate ln x, then multiply your final answer by 2, okay, as we did here, or you can just go directly and differentiate the way that it's appearing. You still arrive at the same answer, okay? Easy stuff. Easy, 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 easy stuff. All right. Now, we can do product rule. Product rule. Now, in mathematics, what does the word product mean? Are you adding, subtracting, multiplying, dividing? What does the word product mean? What does the word product mean in mathematics? Tumonenga mwadishi wetsungu. But nafyo tsungu bati ama product tamwishive. When they say product in mathematics, what mathematical operation are they referring to when they say product? What mathematical operation are they referring to when they say product? What mathematical operation? Times. All right, so they are basically referring to multiplication. Good. So product rule is going to apply to functions. So this applies to functions that can exist individually but have been expressed as a product or multiplied. Okay, so product rule. This applies to functions that can exist individually but have been expressed as a product. E.g., they may ask you to find d dx over x ln x. So x can exist individually, ln x can exist individually, you get? And these two things are multiplying each other. Or d theta of maybe cos theta sine theta, you get? This can exist individually, this can exist individually, but they have multiplied them. So this is where product rule applies. Now, for product rule, you have to pick u, so pick u and v, okay? So u is the item that appears first. So in this case, my u would be x, you understand? And then v is the item that appears second. In this case, so this could be my u, this could be my v. This could be my u, this could be my v. Because if you follow the alphabet, u comes before v. Okay. So, what is the product rule? The product rule, remember, do you remember the word prime? Prime. If I say y is equal to maybe e to the power x, and they say find y prime. Y prime basically means find the derivative of the expression for y. You understand? Okay. Yes. So y prime basically means find the derivative of the expression for y. So whenever you hear me say prime, I'm referring to the derivative of that item. So the formula for the product rule. Product rule. So product rule is going to be, you write your u plus and then you write your v. The order doesn't really matter because you are adding them. Addition is commutative. When you write your u, you are going to put v prime. When you write your v, you are going to put u prime. So it is uv prime plus vu prime. Or you can write it as vu prime plus uv prime. It doesn't matter. So u is the original u. V, this is the original v, okay? Then v prime, it is the derivative of v. Derivative of v. U prime is going to be derivative of u. Hopefully this makes sense. So just remember the formula, u plus v. V prime, u prime. You see that? U prime, u v prime plus v u prime. Okay, so let's answer this same question that we started with. What would be the answer for such a product? Okay, let's go. So find d dx over x ln x. So we said this is going to be our u, this is going to be our v, okay? So u plus v, then this is going to be v prime, this is going to be u prime. I'm just going to substitute. So I know u is equal to x, and I know v is going to be ln x. So I substitute them. Where there's u, I'm going to put x. So x multiplied by v prime. The derivative of v, the derivative of ln x, this is logarithmic differentiation. You differentiate the x and then divide what you get. So the derivative of ln x is basically just going to be 1 over x. So 1 over x, yeah, plus v. My v is ln x, and then multiply by u prime. Now, I need to be careful. I'll prefer to, okay. I need to be careful. Now, this x will not multiply whatever I get here, right? In fact, let me just put these in separate brackets. So, my u prime here, the derivative of x is just going to be 1. Okay, so x and x will cancel out. I'm going to be left with 1 plus ln x. So that's my answer for the derivative of x ln x. We do another one. Find d dx of sine x, sine, okay, d theta of sine theta cos theta. D theta of sine theta cos theta. So quickly, this is going to be my u, this is going to be my v. So u plus v, v prime, u prime, okay? So my u is going to be sine theta, this is going to be sine theta multiplied by that, plus this is going to be cos theta multiplied by that. Here, my v prime is going to be the derivative of v. Remember the mnemonic state cancel? I am moving against, I'm starting with c, so cancel, I'm going to state. So the derivative of v, or v prime, is going to be negative sine. So negative sine theta, okay? Plus cos theta times u prime. U prime is the derivative of sine. State cancel, I'm starting with s, I'm going to positive c. So the answer is going to be cos theta, okay? Then simplifying this negative will come this side, so this is going to be negative sine squared theta plus cos squared theta. Now, because of this negative, I can't replace with the identity sine squared theta plus cos squared theta is 1 because of this negative. Actually, the correct way to write this is going to be cos squared theta minus sine squared theta. Okay, hopefully that makes sense. Hopefully that makes sense. We now go to implicit. We quickly have to do quotient true, and then we go to implicit differentiation. And this question is going to come. Quotient true. Now, when do we get a quotient? When do we get a quotient? What is the word quotient associated with in terms of math? When do we get a quotient? What mathematical operation is associated with quotients? You can comment. What mathematical operation is associated with quotients? Excellent. Division. Is that not difference of two squares? You could express it as that, no problem. So division, yes, excellent. So you are going to have a numerator and you're going to have a denominator. Okay, so quotient true should only be used if you are dividing. And how do you know you're dividing? When you have a numerator and you have a denominator. You get? So quotient true, the formula is going to be, now I'm going to ask you the alphabet A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. My focus is U and V. I want us to use a mnemonic that you guys are not going to ever forget. Imagine A is the youngest. If A is the youngest, then Z is the oldest. Okay? A is the smallest, then Z is the largest. So it's like you increase. A is the smallest, then B is larger, C is larger, D is larger, and so on. So when you reach U and V, which one is larger, U or V? If we are going to use that notation, which one is larger, U or V? Which one is larger? Is it U or V? Which one is larger, U or V? If we use this orientation that we have used, which one is going to be larger, U or V? Quickly, so that we move together, we move as one. This is going to appear very silly, but once you get what I want to teach you, it will make sense. Which one is larger, U or V? U or V? So someone says U, someone says V, someone says V. So let's assume A is 1, B is going to be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Maybe U will be 21. V is going to be 22. So V is going to be larger. Makes sense, right? Now, which one makes more sense? U minus V or V minus U? Which makes sense? Which one makes more sense? V minus U or U minus V? Which of these two makes sense? If V is larger, which one makes sense? U minus V or V minus U? Which of the two makes sense? Quickly. The second one. So V minus U makes more sense because V is larger, U is smaller. Excellent. So always stick to this. So the quotient true, the formula, quotient true, the formula is going to be V minus U, because this is what makes sense. Then divide everything by V squared. I hope you guys are following. V minus U, and then divide everything by V squared. Now, if you remember product rule, whenever I wrote V, we put U prime. Whenever I wrote U, we put V prime. The same is going to apply here. So V minus U over V squared. Then this is going to be U prime. This is going to be V prime. Hopefully this makes sense. So this is the formula for the quotient rule. Now, we need to define what item represents U and what item represents V. Okay, so U is the numerator. And then V is going to be the denominator. Okay, U is the numerator, V is going to be the denominator. Easy stuff. So if I've been given an expression, for instance, find d dx of maybe x over cos x. This is going to be my U, this is going to be my V. So the numerator is always U, the denominator is always V. Now let's do an exam question. And then you guys are going to have some homework. Exam question. Let me just see if I can show you. Okay, let me just quickly show you something so that you appreciate this more. Find the derivative of let me just quickly show you. I hope you'll be able to see. I hope you guys will be able to see. Okay. Do you see this? Show that d dx of tan x is sec x. This is actually an exam question, so pay attention to it. Okay. So find the derivative of tan x. Now, if you're not careful, you may not realize that tan is actually a quotient. How else can tan be written? So they're asking you to find d dx of tan x. Or they could say d theta of tan theta. It doesn't matter what variable they use. How else can tan be written? And remember, the mnemonic state cancel also applies to tan. How else can tan be written? So wakupera mu exam. Find the derivative of tan. So at least you need to know tan can be written as excellent. So sine over cos. Good. So d dx of tan theta is as good as d dx of sine theta over cos theta. You see that? Or if you're using x, you can just put x's. So tan is actually a quotient. Now, remember, we said the numerator represents U and then the denominator represents V. Okay, so this is going to be U, this is going to be V. If you remember the formula, we said the derivative is going to be V minus U, because V is larger, divide everything by V squared. This is going to be U prime, this is going to be V prime. We've said U is going to be sine theta, and then V is going to be cos theta, because the denominator is always V. So I start plugging in. This is going to be, where there's V, I'm going to put cos theta. This is going to be cos theta. I'll put brackets so that I can substitute the derivative, minus U is going to be sine theta. I'll put brackets as well so that I can substitute with the derivative. And then everything is going to be divided by v squared. V squared is cos theta. Now, when you square cos theta, please, cos theta, when you square it, the answer is not cos theta squared. Nope. Please do not make this mistake. Instead, cos theta squared, this is cos squared theta. So this is basically just going to be cos theta, and then I will square it. Then I plug in the derivative of u. U is sine theta. State cancel. If I'm differentiating sine, I'm going to end up with positive cos. So the answer here is going to be cos theta. V, cos theta. The derivative of v, which is v prime, is going to be negative sine theta. So this is going to be negative sine theta. For those that are not familiar with theta, we can still do it with x. It doesn't matter. Believe you me, data and data. So cos theta times sine theta. This is going to give us cos squared theta. Now this negative and this negative are going to give us a positive. So plus sine squared theta divided by cos theta squared. When you square this, this is going to give you cos squared theta. Cos squared theta. Now, if you look at this, recall the identity. Recall the identity. Cos squared theta plus sine squared theta is equal to 1. So remember, we couldn't substitute earlier because we had a minus in between. Right? Now we have a plus sign, and this is actually part of an identity. Whenever you see cos squared plus sine squared, you are always going to replace it with 1. So I'm going to have cos squared theta plus sine squared theta divided by cos squared theta. The top part can be replaced with 1. So this is just going to be 1 over cos squared theta. Cos squared theta. Now, whenever cos is a denominator, how else do we write it? Whenever cos is a denominator, how else can we write it? What is 1 over cos? What? Plus tan? Nope. When cos is a denominator, how else can we write it? Okay, some people are saying sec, some people are saying cosecant. Which one is which? Remember, using mnemonic, state cancel. If you have cos as a denominator, you should write it as something that starts with s. Okay. Yeah, so this is going to be sec. So this is going to be sec. Now, because the cos is squared, the sec is also going to be squared. So 1 over cos squared theta is the same as sec squared theta. The only difference is we used, I hope you guys can see. The only difference is we used theta and they used x, but the principle is still the same, so don't worry, okay? So whenever they ask you to differentiate tan, the answer is always sec squared x, and you know that tan is actually a quotient because tan is sine over cos. Sine is going to be your u, cos is going to be your v, and then you write the quotient through, and then you recall the identity that sine squared plus cos squared should always be replaced with 1. Easy stuff. Okay, easy stuff. So whether we use theta or we use x, alright, easy stuff. Now here's your homework. And let me tell you something about these homework questions. Some will do them, others won't. But ask yourself, who benefits at the end of the day from doing these homework questions? It's you understand? It's better you make your mistake and you're corrected early enough, as opposed to you going on with the same issues. So it's better you make your mistakes, or you confirm that you're doing the right thing, and so on. So always hand in these homework questions. I want you guys to find D, those that wanted the x, narami pela x, d dx of cot x. Okay, so A, I want you to find d dx of cot x, and then I also want you to find d dx of okay, just do cot x. Just do cot x, d dx of cot x. Okay, so we shall meet later to do implicit differentiation. Now, the meeting may be random, so just be prepared to go live with us anytime. Okay, I'll just text, okay, we'll be going live in 10, or we'll be going live in 15. So just be prepared to go live at any time. If you still won't manage to follow the video live, you can always watch the video later. All right, have a good day. We shall meet later today.